INR.
No, you said if I need public IP address, I am going to request my service provider. Like here you can see this is my edge router. Is my screen visible now?
No.
No, sir.
No, sir.
No, sir.
This is my topology. If topology is not clear to anyone, then first guys tell me about topology. Like topology is clear to you. If topology is not clear to anyone, you can ask what is not clear to you. Simple two sides are there. You can see side 1, branch 1 and branch 2. Let's say this is my DC data center and this is one side, remote side, or let's say side 1. And both the sides are connected through service provider. Here you can see ISP1 and ISP2. Maybe let's say ISP1 is Airtel. This is Airtel ISP. Airtel, and this side we have Jio or Tata Communication, Tata or BSNL, any ISP. And guys, see, the good thing is both ISP networks are connected to internet, right? ISP and internet are going to use public IP addresses, right? You know, there are two types of IP address. Can anyone tell me why we divide IPv4 address into private and public? Can anyone tell me
Sir,
why? Yeah.
internet, the routable IPs over the internet are public IPs,
No, that
and
I know.
inside the
Limitation in IPv4 32-bit.
That I know that like in the public network, in ISP or internet, we are going to use public IP address, and in my private, I am going to use private IP address. But why? What is the benefit?
To conserve IP.
What is the benefit?
IPv4
is
shortage.
yes, shortage of IPv4 address. So how we are reducing? We are allowing customer to use same private IP address. Within the organization, you have to use, guys, unique subnet, but between the organization, two organizations can have same subnet. You had seen that in MPLS L3 VPN, while MP BGP VRF, remember, right? Two different companies were using same IPv4 subnet. Am I right?
Yes, separate VRF.
Right. So how we have reduced the shortage of IPv4 address? By doing something, by dividing private IP address into two parts, private and public. And then we said, okay, let's allow customer to use same private IP address. Within the organization, they need to use unique subnet, but between the organization, unique same subnet. But question is, if two customers are going to use same private subnet, then how internet router will identify that this private, let's say one side is in Delhi and one side is in Bangalore, Delhi and Bangalore, two sides. Or let's say this is my company, I am using the subnet 10.1.1.0 private subnet, 10.1.1.0 in the Delhi. Okay, and here is another company somewhere, let's say in Mumbai, and this company is also using same private IP address. So guys, service provider can route the traffic. Can service provider route the traffic? No. Can ISP2 route the traffic? Can ISP1 route the traffic? Can internet router route the traffic? Answer is no. Guys, a router maintain routing table or FIV table, RIV table, LFIV table, switch maintain MAC address table. So if ISP routers are going to install this subnet from Delhi or Mumbai, like both sides we are using, both customers are using same subnet, guys, then ISP1 can only forward traffic of Delhi, because it is learning same route. Maybe doesn't matter which routing protocol is running, but same route is coming from two sides, and definitely from this side it will have lower metric, right? Yes. So it is not possible now we cannot allow multiple customer to use same IPv4 subnet. Then what is the solution? Let's divide IP address into private and public, and we'll use one public IP address for one customer. Now for an example, this is the company, my company, XYZ company. The XYZ company need, let's say, how many IP address? 1000 IP address, right? Or maybe I have somewhere on other side, right? The network size is huge. Then I can purchase 10.0.0.0/8 IP address. Like I can use it. This is private IP address is free. I can use this main subnet, and after that we'll perform subnetting here. For each site, each department will perform subnetting. And here we have lots of IP address. So what it's saying, the concept, what is the main concept? Main concept is just donate this subnet with one IP address, and that is going to be public. That is going to be public, means this whole private subnet will be represented by, let's say, 1.1.1.1, the public IP address, and service providers are going to forward traffic on the basis of this public IP address. So service providers are not going to install customer networks in the routing table. No one, even not ISP1, ISP2 or internet router. No one is going to install private subnet in the routing table. Here for an example, okay, if I need public IP address, the step is I will request to my service provider. My service provider will have the again pool of public IP address from RIR, and INA is managing these all thing globally. So let's say here I have purchased one subnet 1.1.1.0/20/ let's say 30, because I only need 2 IP address. So I will purchase /30, guys. /30 and /24. Which one will be more costly? Which subnet will be more costly? /24. Because how many IP addresses are there? 254 IP addresses are there. So whenever you have pool of servers in the LAN and you want that internet user from the internet like you should be able to access your server. Let's say here I have one web server, and what I want, that all internet users should be able to access this server. The public user on the internet, good people, bad people, both. Everyone from the internet, means with the public IP address, can access my server. In that case, if you have multiple server, you need multiple public IP address. In that case, we need public IP address for our servers. There are two options. I can configure the public IP address directly on the server, and through BGP I can advertise it to my ISP. Then all the router on the internet will have information about my server. First option is advertising your public subnet to internet. On the internet you are only allowed to advertise public subnet. So first you have purchased the public subnet from service provider, and your service provider from RIR. And then, guys, hello.
Yes, sir, listening.
We will be assigning it to the interface.
So in that case, when we have lots of servers, then I can use, you purchase /24 and one public IP address for one server. And the another option is by configuring a static NAT here. You can configure the private IP address on the server, and here on your edge router, you can map one public IP address into one private IP address. That is one-to-one mapping. Means one public IP address will be mapped with one private IP address. For an example, here my subnet is 2.2.2.2.0/24, or let's say 100.1.1.0/24. Let's make it more realistic. Right? So on router number 1, router number 2, what I will do? I will configure one NATing, where I will translate 100.1.1.1 into let's say in the LAN side, I have subnet 20.1.1.0. So here IP address is 1 like this. Right here my subnet is 20 in the LAN side. Very good. So this type of NAT is going to be, guys, bidirectional NAT. Means, see, you can also access internet and internet can also access you. Means if anyone is going to send traffic on this IP address, this public IP address, your router will translate it into this private IP address. And after that, on the basis of the routing table, it will take forwarding decision. Or if
So 20 also public IP. 20 network is also public.
Public, here I can do one thing.
10.
Then 192.168.10.0/24.
1.
Is it fine?
Yes.
Let's
Okay.
set to this IP address. This type of NAT is, guys, bidirectional NATing. Means you can also access internet and internet can also access you. If someone is going to hit on this public IP address 100.1.1.1, it will translate it into this private IP address. Or if someone is going to hit on this private IP address, it will translate it into this public IP address. And I can map how many IP addresses? How many IP addresses can be mapped, guys?
255.
254. 254 valid IP addresses are there in this subnet. Right? So now, guys, most important thing, service provider, let's say, is I have purchased this subnet here between ISP1 and internet. I need 2 public IP address for 2 sites. So, guys, even I am not going to configure IP like this. I will purchase directly /24. I will purchase 1.1.1.0/24, and after that I will perform subnetting. First I need 2 IP address, so let's use /30. Then for the second site 1.1. What will be the network ID? Next network ID. Next network ID, guys.
4.
3.
4 na? 4.
Yes.
Right? For next site 1.1.1.8
1.1.8.
8/30. Right? If somewhere I need, let's say, 6 IP address, then 1.1.1.12/ let's say 26 or 29, right? So like this we can perform subnetting, and for the future also I will keep some public IP addresses, right? That is going to be backup IP addresses. Getting my point? And guys, even here you can see I don't have redundancy. So if I will talk about the real time in the production, in the good companies, you will have multiple edge router here and multiple ISP at each side. At side 1 here, only one ISP is there. Let's understand the technology first. After that, we can see if we have multiple ISP and multiple edge router, then how we'll configure the scenario. Till here, everything is clear?
I
Yes.
have a question about netting.
Yes. Yeah, I'm going to start netting now. What I told you earlier, we were using, guys, older WAN technology. After that, internet. But in the internet, what is the issue? See, on the internet, there is one issue. Let's say this is my DC data center. And like this, branch 1, I have 1000 number of sites. Side 1 to side 100. So how all the sites are going to site 1? How all the sites are going to communicate? I need one firewall at each side. Correct? Yes. So instead of installing one firewall at each side, I will install firewall here in my DC. Here I am going to connect one firewall. Firewall with switch, let's say. And every time when 2 sites want to communicate or want to reach internet, will configure routing to first route the traffic towards firewall, and after that firewall will inspect the traffic and then it will take decision. Centralize. But what happened later? Later we started putting our services on cloud. Here earlier I had all the application, let's say voice application or any critical application. Now that application is shifted to cloud. This application is now shifted to cloud, maybe our AWS, yeah, shifted over cloud means like your AWS is so popular, then GCP,
Google. Azure.
Google Cloud,
Oracle.
Azure. Now application is here. Now see, if this user, here is one user who want to access this application, this is the voice application. You know, voice is delay sensitive traffic, delay should be minimum. So if this user want to access this application, first they will reach to DC through internet only to firewall, correct? Now my firewall is going to inspect the traffic. Who are you? From where you are coming? Where you want to go? Let me check the predefined policy. Are you going to internet? Okay, cloud application is reachable over internet. Yes, you are allowed to go over internet. And after that, it will forward to router 1. Router 1 will forward to internet, and then it will access their application. Am I right?
Yes.
Am I right? Guys, there will be delay, right? Yes. This is voice traffic. Definitely 110% will get packet loss here.
Sir, the traffic will
people
go through the
cannot-
same path or the path will be
Two
different?
people cannot communicate. See, if you want to forward the traffic over MPLS or any other transport, you can connect here and you can configure this one as a primary. So I want that my traffic should go in data center via this transport. So doesn't matter over which transport it is going. Over any transport, process is going to be same. This side 1 is in London, DC is in Delhi.
Sir, my question was like first the data went from site 1 to the firewall and firewall rerouted it to the internet. And when the reply will come, it will be from internet to site 1, or is it going to go
No,
from
firewall.
internet to firewall?
See
and then
how I can allow any traffic from the internet to go site 2 directly. Not possible, na? Reply will also come first to firewall. Again, firewall is going to. This time traffic is coming from internet. This traffic is not secure. Even your private traffic is subnet, right? This is the traffic of your company. No worry. So what people start using here, guys, to avoid this issue? MPLS. Because internet was not reliable like today. Even today internet is not much reliable, but MPLS is very reliable and fast transport. So people started forwarding request from each side to firewall through MPLS, and after that our MPLS it will reach to firewall, and then firewall will route it towards internet, and the same way reply will come. But guys, issue over here is, okay, things was working, right? It has improved the performance, no doubt, but this transport was very costly. This is the issue. First of all, company had issue with firewall. Now this is it. So here, you know, today why SD-WAN is so popular. This is the reason. Here SD-WAN, if you are going to shift your infrastructure over SD-WAN, then SD-WAN will allow you, first of all, SD-WAN will ask you to replace this router, right? Not fully replace the hardware, but at least replace the software, right? You need to update the software, and after that, somewhere on the internet you will have one data center, or maybe on the internet or on the cloud you will deploy some controller from where you are going to manage these devices. These devices will be connected to these controllers. From here we can do everything. on my WAN edge devices. So this was the beauty, that centralized configuration, centralized management. Oh my God, troubleshooting is so easy. At the same time, it is also allowing remote site user to access internet, to reach internet directly. No need firewall. This is the reason why SD-WAN is popular in the market. Just guys, give me 1 minute, please. Done, guys. Clear? So don't worry about the SD-WAN. Later you can learn the SD-WAN. Okay. For now, just try to understand here earlier how we were doing the things, because still today, guys, many companies has legacy infrastructure, the traditional infrastructure. In more than 90% cases, more than 90% corporates, enterprises has traditional infrastructure, and there are two reasons behind it why they are using traditional infrastructure. First reason, skillful engineers are not there who can manage the modern technology. This is the main issue. And the another issue is there will be, guys, outage for maybe 1 day, right? For 1 day, right? Not complete down, but there will be some impact on some services for whole days. So here companies need a skillful engineer who has good command on the modern technology. Definitely they will prefer to shift, because SD-WAN is, guys, not costly technology. This is cheaper technology. The traditional WAN is even more costly than SD-WAN. In the SD-WAN, you can use to transport both transport can be internet as well. Both transport can be internet. And technology is not going to work on your physical WAN infrastructure. Our physical WAN infrastructure means WAN network, it is going to create again VPN, because every time, you know, like two private site will communicate together our public network through VPN. It can be L2 VPN, L3 VPN, like which we have already seen in the MPLS, right? EVPN or VPLS, or GRE, or SD-WAN. SD-WAN is also one VPN, which is connecting multiple private sites over any transport. So the first topic over here is NAT. What is NAT, guys? NAT is used to make communication between private and public network, or public to private network. What I told you, by default two private site cannot communicate over public. Now what I am saying, private site or private network cannot communicate with public network by default. Here, let's say from my ISP I have purchased this subnet. Now let me keep it here. Here I have subnet 1.1.1.0/30. From the ISP I purchased this public IP address, and this side my public IP address is, for an example, 2./0, and they will be using any IP address here, any public subnet between ISP and internet. Let's say here 100.1.1.0/24, and here let's say 100 1.1.2.0/24 or /30, right? /30, and here 0.4/30. And any routing protocol will be running between ISP and internet. Which routing protocol will be working, guys? Tell me. We have already
Default.
discussed.
BGP.
BGP. Very good. Very good. I am expecting this kind of answer. Very good. BGP will be running between ISP and service provider, like internet. Let me configure the scenario, and here my private subnet is this one, here my private subnet is this one. First let me do the IP configuration here. Go to ISP1. I am configuring ISP network first. ISP1, ISP2 and internet. Internet router will have IP configuration first, interface F0/0, no cert. All the router on the internet will have this configuration and some ACL. I will show you that also. IP address 100.1.1.2, let's say 255.255.255.0. I will configure .1 on ISP1, or let me use .1 here and .2 on ISP. Then interface F1/0, and here IP address is going to be 5 na
/30.
okay.
Sir, we will not configure the purchased IP here, the public IP purchased.
We have purchased the public IP address.
On this interface, we will not configure the purchased IP.
So the ISP is going to purchase the public IP address now for this interface. ISP already have lots of public IP addresses, lots of public subnet. Why you will purchase public IP address for internet? This is ISP, Airtel. This is ISP. From ISP, you are going to purchase the public IP address, this public IP address, this and this. This is your public subnet. This is also your public subnet.
Right. Okay.
So here what happened? Do so run interface F0/0. Interface F0/0. Done. And IP address 100.1.1 255.255.255.252, and then interface F1/0, again no cert.
One 1.4 we can assign. 5.
100.1.5.1 1.5.
0.5.
0.5, 1.5 here. Done. Then they can enable BGP router BGPS number 100. Let's say iBGP, or let me configure eBGP, because between ISP and service provider there will be eBGP. Here you will be using public ES number. Public ES number neighbor 100.1.1.2, and remote ES.
It's network.
And remote AS, let's say 1 for ISP1. And internet router is not going to advertise any prefix. one more neighbor, that is 5, then 6. Then go to ISP1, config T, interface F1/0, no cert, and IP address. What will be IP? 100.1.1.225.255.252, and interface F0/0, no cert, and IP address 1.1.1.225.252, and router BGP is number 1, and neighbor 100.1.1.1, and remote is 100. And when you will purchase this public IP address 1.1.1.0 from the service provider, it is going to advertise this network in BGP 1.1.1.0 and mask. What will be the mask? What will be the mask? 252, right? And on the internet router, now you can see, so IP route BGP. Through BGP, it is not learning any prefix. Okay, I am on ISP2, sorry, on the internet router. So IP route BGP. See, 1.1.1 is available, and 1.1.1 is managed by ISP1, which is Airtel, by Airtel, right? To connect your site, to provide WAN connectivity to your private network, right? ISP1 is connecting your private network to public network with this public subnet, and it has advertised it in BGP. Through BGP, it is advertising our internet, our public network. This is another benefit of dividing IP address into private and public. Again, say no such and IP address. What will be the IP here? 100.1.1.6, 255.255.255.0, and interface F0/0, no such, and IP address 2.2.2.
Subnet mask slash
Okay.
252 subnet mask.
Done. Router BGP is number 2 and neighbor 100.1.1.5 and remote is 100. And the network 192.168. Sorry, network 2.2.2.0, 255.255.255.252. Guys, I am getting notification message. There is some issue. Do so run section BGP. On internet router. So
On internet router, I think
here is the issue.
AS number is 1 for this.
Okay. Router BGP 100, neighbor 100.1.1.6, and remote AS 2. Now BGP session is up, and now on the internet router, now you can check. So IP route BGP, both the public subnet should be there. So IP BGP summary on the ISP2 network 2.2.2.0, subnet mask 255.255.255.252. Done. And now on the internet router, so IP route BGP, you will have 2.2.2 as well soon. Very good. Now it's time to configure customer router. Now you can see internet, like all the ISPs are reachable with each other because all are using public IP address. Now ISP will do one thing. ISP is going to only allow this subnet on this interface F1/0 to forward traffic from this interface. I am going to apply one access list which will only allow this subnet, not any other subnet, not public, not private. If you are going to use another public network here, you have to talk to your ISP. Done. So it will configure ACL like access control list, let's say 10 permit and 1.1.1.0 wildcard mask. What will be the wildcard mask? Wildcard mask for /30.
3.
3.
3.
3. Right, and guys, there is implicit deny, means in this ACL we are only allowing this submit, right? Rest all the IP address are denied automatically, or you can define also access list number 10 deny any, rest all are denied. Do so access list. Here you can see access list number 10, two statements are there, one with sequence number 10, one with sequence number 20. Sequence number 10 is saying permit 1.1.1.0 with this wildcard mask, and 20 is saying deny everything, and now it will apply it on their interface like this. Now I am going to close the console of ISP routers, because ISP routers will not perform any configuration now. Now it's your turn. Configure your customer edge router. Let me access R1. Are you guys getting me? What I am doing?
Yes. Yes.
Sir, we have not applied the access list.
You can apply it na on the interface. ISP will apply it. ISP can allow multiple submit. To apply the access list, you have to run command access group, access in number, and then direction. That's it. Nothing else. If I will apply the ACL with BGP, then BGP can only advertise this subnet to the internet router, right? Now let's configure the customer router R1 and R2. R1 and R2, both router have public IP address, guys. So if I will configure the public IP addresses on my edge router, can R1 and R2 communicate publicly with the help of public IP? Config T,
Yes.
interface F1/0. No cert and IP address. What will be the IP? 1.1.1.1 255.255.255.252, and on router number 2 also let me configure interface F01/0, no shutdown, and IP address 2.2.2.1 255.255.255.252. Now let me take you to R1 and let's check connectivity. Go to R1 and say ping 190 2.2.2.1 and enter. Why ping is not working? Because route is not there on the customer router. And guys, I have connected my router to ISP. Everything is over internet. So either you can advertise on default route here, but if you don't want to access internet through this internet transport, guys, let's say this internet is actually not in use to access the internet. For that I have another internet connection. This transport is just connecting two sides. For the VPN I have purchased this link, this WAN network, public network for the VPN. It can be your transport only. So at that time you will not configure default route here. You will configure default route here. In that case you will configure on a static route for this remote public subnet, right? So you tell me, should I configure a default route or a static route? Now, you want to use this internet to access every public server or just to connect two sites, not more than that. We don't need internet for now. By the way, I need internet because I am going to configure NAT. So let me configure the default route 0.0.0.0 0.0.0 f1/0 and next hop IP will be 1.1.1.2, and on router number 2 also I will configure one default route towards internet ISP IP route 0.0.0 0.0.0 f1/0 and next hop IP address 2.2.2.2 and go to R1 now and ping, check connectivity, and now you can see ping is working, right? Now my two sites are reachable publicly with the help of public IP address. Always keep in mind, your private subnets are only allowed to forward public packet over internet. ISP cannot accept your private packet. When you will forward any packet to ISP1, then destination IP address should be this one 2.2.2.1. Let's say this user is going to ping this private IP address 192.168.10.1, this user PC1. So they will forward traffic to their gateway, and router 1 have to add source 1.1.1 and destination 2.2.2. Then only these two sites can communicate. Then only ISP1 can route the traffic because ISP only knows about the public IP address. Am I right?
Yes, sir.
So guys, if I want
Right,
to
sir.
access internet here, let's say
Yes,
on the
sir.
internet there is one server 8.8.8.8 is one server on the internet. Let me do one thing. Let me create one loop back here on 8.8.8. Ping 8.8.8. Sorry, not ping. Config T interface loopback 1 and IP address 8.8.8.8 255.255.255.255 for an example. That's it. On the internet, just I have added one server. That's it. Now guys, let me ping internet. Ping 8.8.8. Any server on the internet is reachable? Yes. No, not reachable now. Why it is not reachable? Can anyone tell me why ping is not working here when I am pinging 8.8.8?
Not addressing network.
ISP
Not in
routers,
BGP, sir.
ISP routers don't have route for 8.8.8. When you are generating the traffic, your router 1 is generating the traffic for 8.8.8. So source IP address is going to be 1.1.1.1. Their on exit interface IP address and destination IP 8.8.8.8. It will check routing table. There is one default route towards ISP1. Right, so it will use that default route to forward traffic to ISP1. ISP1 is going to compare destination IP address with their routing table, and in their routing table you can see do so IP route 8.8.8.8 not reachable, not in table. So ISP routers will also advertise one default route through either BGP or they will configure one default route towards internet f1/0 and 100.1.1.1 or 2 guys. On the internet side 1 I think, and ISP2 will also configure default route towards internet IP route 0.0.0 0.0.0 and exit interface f1/0 and next hop IP address 100.1.1.5. Done. And now go to router 1 and try to access internet, and now you can see internet is reachable. Internet is reachable. Very good, because this is public IP address. That's why it is reachable. Can I ping 8.8.8 from the private IP address? And now guys, from router number 2 also you can check. Through public IP address you are able to access internet. From here also ping is working. But through private IP address you cannot access. Reason? Go to R1 and let me configure the LAN interface also. Interface F0/0, say no shutdown, and IP address. Let's say IP 10.1.1.100 gateway 255.255.255.0 exit, and let me ping 8.8.8 with source 10.1.1.100 means PC is pinging. You can see ping is not working. Can anyone tell me why ping is not working? Or here on
Access
PC?
list.
Not access
Public
list.
IP,
Access list is not apply.
NAT is not there.
Which router is dropping the traffic? Guys,
Our-
when this user will generate traffic whose IP address is 10.1.1.1, IP is 10.1.1.1 and the gateway IP address is 10.1.1.100. When the PC will generate traffic, source IP will be what? 10.1.1.1, destination IP will be what? 10.1.1. Sorry,
100.
8.8.8. It is
8.8.8.
accessing internet. 8.8.8
8.8.
and source MAC will be the MAC address of PC1, destination MAC will be the gateway. Traffic will reach to R1. R1 will compare destination with routing table. Is route available on router 1? Yes, there is one
Yeah.
default route.
Yeah.
So
yeah.
IP
Yes.
route. Default route is there towards ISP1. Right? It will use this default route to forward traffic to ISP1. ISP1 is again going to compare source with destination with routing table. So IP route. Very good. See, for 8.8.8 destination 8.8.8 there is one default route, right? ISP1 will forward traffic to internet. Now internet router is going to check their routing table. So IP route. Wow, 8.8.8 is directly connected. Am I right, guys?
Yes.
That means traffic is for me. Even you can see here traffic is reaching to internet. Here I can use debug command, debug IP NAT, not NAT IP packet or IP ICMP, and then go to R1 and generate ICMP traffic again. Ping again to 8.8.8. See on the internet router is generating the reply where source is 8.8.8 and destination is 10.1.1.100, which is private IP address. Now internet router can not forward the traffic. Here route is not there. Here we don't have any default route, right? So ISP router is generating the reply, but it is not able to route the traffic because route is not available. Is it clear? ISP router will drop the traffic. What I told you, you can reach to internet with this IP address only. Your private IP address should be this one instead of this private IP address 10.1.1.1 because ISP router or internet don't have route for private subnet. So
The
the
reverse
technology
path is not present, na? That's why.
yeah. So the technology which we are using to make communication possible between private and public network is NAT. By default, private and public network cannot communicate. And the technology which we are using to make it possible is NAT, network address translation. In the NAT, first of all, you have to define which interface are LAN interface and which interface is WAN interface. Means where you are running the public subnet and where you are running the private subnet. For an example, on R1, see I am not able to access even from the PC. I cannot access internet 8.8.8.8. When PC will generate traffic, then also on the internet you can see it is generating the reply. This time it is generating reply for 10.1.1.1 PC1, but it is not working. So let me configure NAT on router number 1. Config T interface F0/0. First of all, I am saying this interface is your LAN interface connected to inside network. IP NAT inside, and interface F1/0 is your IP NAT outside. Done. After that, guys, you have to tell which private subnet you want to translate. What is the subnet, private subnet? So to match the private subnet, I can use access list. Let me use access list number 10 and permit 10.1.1.0 wildcard mask 0.0.255. And now we can enable the NAT, we can configure the translation. Let's say IP NAT inside. Whenever you will receive the traffic on inside interface, then NAT it. NAT stands for network address translation. Whenever you will receive the traffic on inside interface, IP NAT inside, and if source is matching from list number 10, IP NAT inside, source 10. If you are receiving traffic on inside interface where source IP address is matching from ACL number 10, and in ACL number 10 your private subnet is matching, you can see here, then translate it, IP NAT inside source, translate it into the IP address which is running on interface F1/0. Getting my point? That's it, guys. This is a NAT configuration. What I am saying, translate the traffic where source is matching from ACL number 10 and you are receiving on inside interface, and I have already defined which interface is inside. Then translate the source with the IP address which is running on F1/0, and to enable PAT, port address translation, here you can use one keyword, that is overload. Source list number 10, interface source list number 10, IP NAT source list 10, sorry, list was missing, F1/0, and then overload to enable PAT. What is happening? MUTAM interface F1/0 overload. Done. And now if you will check from your PC that your PC is able to access internet or not, then yes, guys, you can see it is able to access NAT. Why it is able to access, sorry, internet 8.8.8? Because you know, see the router 1. On the router 1, see what happened. So IP NAT translation. What happened when user generate the traffic? You can see inside local. Inside local means F1/0. Inside local IP address is 10.1.1.1, which is PC1 IP address, and it has translated into outside IP address which is 1.1.1.1 in inside global. With inside global, let me tell you about the NAT John. Guys, this private subnet is called inside local. Your public subnet, your private subnet is inside local IL. This is inside global, local and global, inside global. And 8.8.8, you know, 8.8.8 is like, let's say, Google network, Google servers. So their networks is also connected to internet through public IP address. So outside local is Google, and outside global is also Google, because Google is using public subnet, right? So you can see outside local as well as outside global is 8.8.8. There is no any change, which is your destination IP address. So router 1 has not play with destination IP address. Destination IP address was 8.8.8 at PC1, and it is still 8.8.8 at router 1. But source IP address, which was 1.1.1 earlier, is translated into this public IP address 1.1.1.1. Even we can do one thing here, we can enable debugging to verify the translation, that how it is performing translation. Let me say debug IP NAT, and then go to PC1 and generate the ICMP packet again. See the translation, what it's saying. We have enabled PAT, guys, by the way, right? Here is the entry. You can see the NAT entry. Entry assigned to ID number 10, right? The port number, we have enabled the port, so that's why it have assigned the port number as well. By the way, ICMP protocol does not have port number, so your NAT is added the port number as well. Then source from 10.1.1.1 to 1.1.1.1, and destination 8.8.8. Entry number this one. Getting my point?
So can you explain inside global again?
Inside global is
which area?
See guys, Google can also have the network, right? Their own network, private network or public network. Like my data center or side one, they will also have their network. Their network will be also connected to internet. So for you, Google network is inside global. sorry, not inside, outside global, sorry. Outside
Yeah, this one
global. And this one is also outside global, the which is connected to internet, because both are same. Google is using public IP address, then even Google network is also on the internet, like the ISP1 network. So whatever configuration here we have, same configuration is going to be on the Google router as well.
Can you draw the area again? Inside global and outside.
This is inside local, this is inside global, this is inside this is outside local, and this is outside global. Outside local, destination. Outside local and outside global is both is destination on the internet.
But in NAT translation in 1.1.1 subnet, here it's showing inside.
1.1 is inside now. I am saying now it is inside global.
Okay.
Inside global, and this is inside local.
No, previously you said ISP1 to internet is inside global.
Router 1 to ISP1 na?
Yeah, router 1 to ISP1 inside global.
Yeah, this is inside global.
Okay.
Again I am saying same na? This is
No.
inside
Previously
global.
you showed. Yeah, previously you said ISP1 to internet inside global.
Again I am saying inside global. It is inside global
from
only na?
From R1 to ISP1 inside global, right?
Yes.
From ISP internet.
From ISP1 to internet.
Yes.
Outside local, or it can be outside global, or both can be same. Even if you are going to ping 100.1.1.1, the inside local is going to be 10.1.1, inside global is going to be 1.1.1, outside global is also going to be 100.1.1, and outside local is also going to be 100.1.1. Same.
Okay.
Ping and then check on router number 1. On all. Let me disable the debugging and see what it's saying. Inside global 1.1.1. What it's saying? Inside local 10.1.1.1. Getting my point? This is inside local, this is inside global. Clear?
Yes. No.
And the public network is outside local and outside global. It can be 8.8.8, 100.1.1.1, and or any public IP address. Right, and here is the translation, how router is performing translation.
Sir, outside local and one more time, please.
Outside local is public network, remote public network.
Okay.
Inside local means my private network. Inside global means my public network, which we have purchased from the ISP. And outside local and outside global is public network.
Okay.